All right, we are back for some flipped classroom stuff this year. The feedback on this was pretty good last year, and I got some really good ideas. If you have some ideas on how to improve or change flipped classroom work, please let me know. One of the pieces of feedback that I did get last year from the uh, high school algebra students especially is that if you go to my website and you want to use the notes and you want to use the video at the same time, that there wasn't a really good system to do that. So what I decided to do is I'm going to pretend that this Word document is my notes, and then I'm going to pretend that this right here is the video that's running. If you go to the top of the screen and you click this blue border and you slide it over until you see that little pop-up like that, I'll show it again, and you let go, it will automatically cover up half your screen. So if you have two documents that you want to be working on at the same time, sometimes you got to shrink it down right away. Okay, you have two documents you want to be working on at the same time, you can have them next to each other. So the video could be running over here on the left, and your notes can be running over here on the right. And it's an easy fix like that, and it's all back to normal. If you don't want to do that, that's fine. Some kids last year did screen capture stuff. They found ways to take photos of the screen. Some people watched it on like their iPod at home. I don't care what you do. As long as you have notes that I can see, then we're fine. On the website, we have the notes for every day. If you want to use the notebook notes that I use in the presentation, they're right here. If you'd like to do them on paper, that's fine. If you want to do them any other way, that's fine, as long as you have them. Once again, you get to use notes in every test and quiz. So let's get started. The distributive property, we learned it when we were younger with something like this. You have order of operations says that we have to do what's inside the parentheses first, so this becomes 2 times 7, which is 14. But the distributive property says that if you do it for the outside numbers as well, 2 times 5 and 2 times 2, you should get the same answer. 2 times 5 is 10, 2 times 2 is 4. Those add together to be 14. It works for subtraction as well. This ends up being 8. This is 20. This is 12. So that actually works too. Okay. Now, if you have a problem like this, 11 times 12, I look at that right away and I go, I don't know how to do that. The distributive property gives you an avenue in order to solve that problem. You break this 12 up into two pieces, 10 plus 2. And you pick 10 because that's an easy number to use. Or not 12, it should be 2. 10 plus 2, this is easy. And then this is just kind of the add-on stuff. So 11 times 10 would be 110. 11 times 2 is 22. You add these together to get 132. So that's why we use the distributive property, okay? Or at least why we used it before. Now we're going to use it for some more stuff. I'm going to take this and slide it down. What the distributive property says is that if you have a number and a parenthesis, that means the symbol in between these is a multiplication. In order to get rid of the parenthesis, we have to distribute this into both numbers, just like we had done before. And the reason why we do it this way now is because we have an X on the inside, so we can't do the inside of the parentheses. So we end up getting 2 times X, like that, and then we distribute the 2 to the 5, and we get 2 times 5. Now the symbol in the middle, there's two ways to think of it. We can look at the symbols for the front. This is a plus here because there's nothing here, and a plus here, so that's a plus and a plus. They're going to become a plus. Or you can think of it of the way that I did last year, and that it's a slight alteration. This is a positive 2. This is a positive X, and this is a positive 5. So you would do positive 2 times positive X is a positive number. Positive 2 times positive 5 is a positive 10 here. So our answer is 2x plus 10. By far the hardest part of this is the symbols in between. Are they positive? Are they negative? That type of thing. Down here, there's nothing in front, but I do notice a number behind, and it's the same structure as this. There should be a multiplication sign. I'm going to distribute in reverse, but should be the same answer. I'm going to go 1 times 8, and I'm going to go plus, because positive, positive, and I'll go 2n times 8. 1 times 8 is 8. 2n times 8 should be 16n, because the 2 and the 8 multiply together. Alrighty, make sure you get that written down. We'll check our time. We're doing okay. To do a couple more, we got some negatives involved here. Now, I'm going to do Ann's method right away. Last year, Ann realized that when you have a variable sitting by itself, it's always easiest to make sure it has a number in front of it. So if I see a negative y here, Ann always changes it to a negative 1y. And I've actually copied that. It makes everything so much easier. Okay, so here I have a 3 and a 1. So I'm going to go 3 times 1, because I'm distributing. And now I have a 3 times a negative 1y. So I'm going to put a plus here, and I'm going to go 3 times negative 1y. Now, if you see that negative and you say, well, why don't you just do 3 times 1 minus 3 times 1y? That's fine. These mean the same thing, and you're going to get the same answer. I honestly don't know which I'll do. It depends on the situation. So I'll do the top one first. I'll move this over here. So I have 3 times 1 is going to be 3. And then 3 times negative 1y is going to be negative 3y. And our old addition says that plus a minus is a minus. So we get 3 minus 3y. And you would probably skip that step, which is okay. Down here it's the same thing. We have 3 times 1 is 3. And we have a negative sign, and 3 times 1y will be 3y. Same answer both ways. Just make sure you don't lose your negative. Down here on the bottom, we have a 1/2 is going to get distributed. So I'm going to get 1/2 times 2x, or 2x times 1/2 means the same thing. And now I'm going to put the minus in here, and I'm going to go 1/2 times 4. 1/2 times 2x will be 1x, or just x. Either way is fine. And here I'll put a minus, and I get 1/2 times 4. Well, a half of 4 is just 2, and that's our answer. Okay, some of you might already be asking, well, can I just skip this step? Okay, I don't want you to right away, but once you feel comfortable with everything, you can skip that step, and you will skip that step. Okay, but just make sure you don't skip it too early, or you'll get yourself confused. Okay, we're going to do our first pause. I want you to try these on your own. Okay, so we're back. The top one here, we should have done Ann's method to turn this into a negative 1n. So I get 5 times negative 1n. And then I'm going to go plus 5 times negative 3. 5 times negative 1n is negative 5n. 5 times negative 3 will be minus 15. Okay, and some of you might already be asking, well, that's different than the ones we just did. Distributive property is so many different types of problems that I will not be able to show you every one. I'm just trying to show you a generalized idea so you can work through it on your own. Down here on the bottom, you should have gotten negative 6p from that times that, and minus 18 from negative 3 times 6. Okay. Oops, went too far. Okay. Tricks on these. We have negatives sitting in front of our parentheses by themselves. Ann's method again, make sure you put the 1 here and the 1 there. I would recommend doing Ann's method on the inside of the parentheses too. And now I'd like you to try this on your own. Okay, so let's see how we did. These are definitely the hardest problems. So if you got these right, congratulations, you are ready to go. So here we have negative 1 times 1x for there. And then we'll have plus a negative 1 times a 4. So I get negative 1 times 1x is negative 1x, or just negative x. They mean the same thing. Here we'll have a plus minus 4 or minus 4, and that's your answer. Okay. Down here on the bottom, we should get positive 1x plus 4, because we have a negative and a negative. Okay, if I break that up, yeah, we get negative 1 times negative 1x plus negative 1 times negative 4. Alrighty, some of you might already be asking, why do we do the distributive property? It's an estimation type problem. So we have 6 CDs selling at $1 or $11.95 each. That means that what you're actually doing in your mind is you're going to go 6 times 12, and then you're going to subtract the 6 times the 5 cents here. Okay? Now, you're not necessarily going to sit in a store and do this estimation, but what you are going to do, and I guarantee all of you will at some point, you're going to say, well, 6 times 12, well, that's $72. So my answer should be just a little bit less than $72. That type of estimation is really, really helpful. Okay, so the same thing down here on these bottom problems. That green is terrible. So I know it's 5 times 20, so it'd be 5 times 20 plus 2. Well, in real life, you're not going to necessarily break that down all the way, but you will do 5 times 20, which is 100. So you know that your answer is going to be a little bit above 100. Same thing over here. You're going to do 8 times 10, and then it's adding the 1. Well, you're going to go 8 times 10, that's 80, so it should be a little bit above 80, or 88 in this case. Okay? The distributive property, when you see it on paper, looks really different, but it's something that we do every day in estimation. Okay? Here's your problems. I would like you to work on those in class. They will be due at the beginning of class tomorrow. Have a great day.